Okay, so this lesson is 11.3, and 11.3 is reflections. Okay, so what we're going to be doing today is we've already done translations. Now we're going to talk about reflections. And reflections as well as translations, I think, are probably the easiest of the two, but rotations become a little bit more challenging, but we'll do that one in our next lesson. So when you're talking about a reflection in sixth grade was probably referred to as a flip. Okay, that is sixth grade terminology. In the eighth grade terminology, that would now be considered a reflection. Essentially, a reflection is a transformation in which the figure is reflected along a specific line of reflection. And in most cases, when we're talking about doing this, we're going to be using the coordinate plane. Okay, so you will usually, when you're talking about reflections, you will reflect along either the x-axis or the y-axis. Okay, so there are essentially two things you're going to do today. You're going to be able to identify whether something is a reflection or not and why. And then you're also going to be able to actually reflect a figure either along the x or the y-axis. Okay, so the line of reflection here is just this given line. When you look at a reflection has it's actually like a mirror image of what you have. There is a tool called a Mira board that I'll have out in my classroom that you can take a look at. And the Mira board will help you. If you put it along the line of reflection, it will reflect it for you and you are able to see through it. It's kind of a neat little tool. But what happens is if it's a slide before or a translation before, we would just move this point over here, and the pointy part of this quadrilateral, this trapezoid, would be over here. And then this one would be here, and this one would be over here. But you notice that the slanted line of your trapezoid is facing the line of reflection, and it is over here as well. That means all you did is flip that red one on top of the blue one, so therefore it is a reflection. Okay, so if you look at A here, A is identifying a reflection. You have to tell whether, and this is what you're going to have to do on part of your assignment, you have to tell whether the blue figure is a reflection of the red figure. So looking at A, you have this blue figure, and then you have a red figure, and this is your line of reflection. Did we just slide it down and make a translation, or did we flip it and make a reflection? So in this situation, it can be flipped. You can flip that blue one. The pointy, it's the opposite mirror image of the blue one, so therefore it is considered a reflection. Okay, it is a reflection because you can flip the blue form on top of the red form. B, you have the arrow type figure here, and this is your line of reflection. Is B a reflection, the red a reflection to the blue? And it is not, because I thought this is really a translation. You are sliding these points over and you're creating a figure that is exactly the same, facing the same direction. Therefore, it is not a reflection. So it is not a reflection because it is a translation. It's a slide. You just slid the points over. Okay, so now doing the same thing, I want you to do numbers 1, 2, and 3. Pause your computer, do 1, 2, and 3. Come back, and then make sure you tell me if it is or is not a reflection and why it is or is not. Okay, number 1. So number 1, you have 1, 2, 3, 4, 5, a pentagon and another pentagon. Is the red pentagon a reflection to the blue pentagon following that line of reflection? And it is not. It is not a reflection. It is not a reflection because it's really, it really is a translation. I really want you to use the vocabulary. It really is I forgot the translation. You are sliding those points down, so therefore it is not a reflection. Number 2, what about number 2? Number 2 is the same thing. No, it's not. It is not a reflection. it truly is, again, translation. And these should be in sentences, okay? I'm kind of shortcutting it, but yours should be in sentences, kind of like the first one. Number 3 is number 3 of reflection, the blue or the red to the blue over that reflection line. And in that situation, it is. Yes, it is. Why is it a reflection? Because the red figure is flipped along the line of reflection to get the blue figure. That's what I would expect for a reason. Okay? All right, so now if you look at the next section, I'm going to have to erase a little bit of this here. If you look at the next section, this is now, we talked about it being just recognizing and whether it is or isn't and why. Now you're actually going to do it on a coordinate plane. So this really becomes more mathematical now. That's the difference probably from 6th grade to 8th grade. Now you're actually going to be doing some math on your coordinates. So to reflect, and this is huge, to reflect a figure on the x-axis, you're going to do the opposite to the y-coordinate. And if you reflect a figure along the y-axis, you're going to take the opposite of the x-coordinate. So depending on what your reflection line is, if it's the x or the y-axis, you're going to take the opposite of the opposite coordinate. So if it's the y-coordinate, your y's stay the same, but you're going to take the opposite of the x's. If it's the x-axis, or x-axis, I'm sorry, y-axis. If it's the x-axis, you're going to take the opposite of the y-coordinates, and the x's are going to stay the same. The x-coordinates are going to stay the same. Okay? So if you look at this first example that we have here, this is on page 481. Notice that if you're reflecting along that x-axis, only the y-coordinates change to their opposites. So this is along, you're reflecting along this x-axis, okay? So our x values stay the same. A here is still -1, and it's still going to remain -1 here. The value that changes is this +1 now becomes a -1. And you do the same thing here. B still stays on -1 for the x-coordinate, but B for the y-coordinate changes. Now, some of you struggle sometimes with making sure, writing it x comma y, making sure you're using the right values. Don't rush through that. Make sure you do that correctly. So that's essentially what you're doing. When you're reflecting along that x-axis, only the y-coordinates change. The x-coordinates stay the same. And they change to their opposite. Okay, so if you look here now, you have reflecting along that y-axis. So again, same thing, except that this time you're reflecting along this line. And when you reflect along this line, now the values of the x-axis are going to stay the same, or y-axis, sorry, because you're doing on the y. The y-coordinates are going to stay the same. The x-coordinates are going to become their opposite. So here, if we look at P, okay, P has a ordered pair of -2, and 5. okay? So over here, the reflection then of P is going to be the same y coordinate. Your y is going to stay the same, 5, but your x coordinate is going to change from a -2 to a +2. Okay, so when along the y-axis, reflecting along the y-axis, the x coordinate changes. The y coordinate stays the same. Okay, so what I would like you to do is I would like you now to practice this a little bit. So you have a figure, A, B, C, and D. It's a rectangle. It tells you here to draw it. I don't care if you draw it. What I want is your coordinates. Okay, I really just care about you doing your coordinates, because if you know what the coordinates are, you will be able to then graph it appropriately. If you want to draw it, you go right ahead. I'm very mathematical, so I think if you can do the coordinates, you can graph it. So I want you to, for A, I want you to reflect these points along the x-axis, and then B, I want you to reflect these points along the y-axis. Not after. Do the x from these points to the x, then from these points to the y, and give me the coordinates. And then I want you to answer question C. Okay? So pause your computer and do that, and then come back. Okay, so when we look at this, when you're doing the x and y axis, the same thing we did before, you're always going to do the opposite. So the first one is along the opposite coordinate. So we're reflecting along the x-axis. So when we're reflecting along the x-axis, since it's the x-axis, the y coordinate becomes the opposite. So for A, our coordinates are going to be, A is going to be, I gotta get to my thing here, -4, 3. B is going to be -4, 1. C is going to be -1, 1. And D is going to be, there's my D, there it is, -1, 3. Okay, you're reflecting along the x-axis, so your x coordinates stay the same, your y coordinates become the opposite. So for B, we're going to do now the y-axis, so I'm just going to put those next to it right here. So for B, my point A is going to now be 4, -3. My A, I'm sorry, my B is going to be 4, -1. I think I said that backwards before. My C is going to be 1, -1. And my D is going to be 1, -3. So this is if we reflect along the, oops, ooh, I can move that, look at that, y-axis. And this is if we reflect along the x-axis. Okay? Now C asks you, are the images in parts A and B congruent, and why? Yeah, they are congruent. Just because they're flipped doesn't change the size of their lengths or their angles. So yes, they are congruent because they have equal side lengths. And they have equal angle measures. You just flipped it. It's still the same figure, so it's congruent. Okay? Okay, so what I would like you to do for your practice problems is I would like you to do, and you have to, for this first part, you're going to do 5, 7, and 9. And you're going to tell me if it is or is not a reflection and why. Okay? Then you're going to do 11 and 13. And you're going to do 15 and 17. And again, you do not have to draw it. It tells you to draw it. I don't care if you draw it or not. If you want to draw it, go right ahead. There's graph paper on my front table, but you don't have to draw it. Okay? And then I want you also to do number 19. on page, what page is this? Page 483, okay? So you're doing kind of a lot of practice problems, but 5, 7, 9, 11, 13, 15, 17, and 19. I want to make sure that you understand it. Okay,